Rhombi and squares, rhombi and squares. Well, we just looked and proved a parallelogram that was a rhombus, and of course, if it's if a parallelogram is also a rhombus, then its diagonals are going to be perpendicular, and also those diagonals are going to bisect opposite angles. Kind of definition of a rhombus. So let's see, but what about a square? Let's see, one other thing about a rhombus, if one pair of consecutive sides are congruent, then that parallelogram is a rhombus. And if a quadrilateral is both a rectangle and a rhombus, then it is a square. So let's see what kind of proof statement we're doing here. Let's see, we are given that SQ is the perpendicular bisector. SQ, I see that there in this diagram, is the perpendicular bisector of PR, and the PR is also the perpendicular bisector of SQ, and triangle RMS is isosceles. Okay, RMS is isosceles. That's going to make sense here in a moment. All right, so let's prove then that this quadrilateral PQRS is in fact a square. Well, let's start. So since, we're restating the given, since SQ is a perpendicular bisector of PR, then QS is perpendicular to PR, which means we got a right angle right here, right? QS is perpendicular to PR. We got nothing but right angles in here because these two are perpendicular. And segment MP is congruent to MR by definition. So these two segments, MP and MR, are congruent. Now let's see what else we got. So since PR is the perpendicular bisector, so bisector of segment, and I should be using segment. Since segment PR is the perpendicular bisector of segment SQ, well then that means that MS, this segment, and QM, this segment, are also congruent. Let's go back then. See, so since segment SQ is the perpendicular bisector of segment PR, then that means that segment QS is perpendicular to PR, and segment MP is congruent to MR, and since PR is a perpendicular bisector of SQ, then MS and QM are congruent. Segments are congruent. Now, since triangle RMS is isosceles, well then MS is congruent to MR. And we can see that in this triangle RMS. So then we can by substitution say that segment MS is congruent to MP. Let's see, let's say MP and MR. So we said that MP, segment MP is congruent to segment MR, and then we said that MS is congruent to QM, and that MS is congruent to segment MS is congruent to segment MR. Okay, well if MR and segment MR and MP are congruent, we can substitute segment MP for MR, and we establish that MS is in fact congruent to MP. Shazam. All right, so let's see. So by definition of congruence and the transitive property, then MS is equal to MP, and QM is equal to MR. So all four segments in those diagonals are equal to each other. And by the segment addition postulate, MS plus MQ equals SQ, okay? Those two segments make up the entire segment of SQ, and then MP plus MR equals PR. Wow. All right, so then by substitution, MS plus MS equals SQ, and MS plus MS equals PR. Okay. We can go with that. So by the definition of congruence, segment SQ is congruent to segment PR. Those diagonals are congruent. Now, that means what? Okay, I think that means it's a rectangle. All right, so let's see. Since the diagonals of quadrilateral PQRS bisect each other, well then PQRS is a parallelogram. All right, so we got that. This object is in fact a parallelogram. Let's continue. And since the diagonals are congruent, quadrilateral PQRS, which is also a parallelogram, quadrilateral and a parallelogram, and since those diagonals are congruent, it's also a rectangle. So we got a quadrilateral, it's a parallelogram. Now we've proved that it's a rectangle. Let's continue. So since the diagonals are perpendicular, parallelogram PQRS is a rhombus. So we've gone from a quadrilateral to a parallelogram to a rectangle. Now, one of the things about a square, if a quadrilateral, we see this in theorem 6.20, if a quadrilateral is both a rectangle and a rhombus, well, guess what? It's a square. So we've just proved, because the diagonals are congruent, that this parallelogram is a rectangle. And now we've just stated that since the diagonals are not only congruent, but they're perpendicular, then this quadrilateral PQRS is a rhombus. Well, diagonals are both congruent and perpendicular, which means that it's a rectangle and a rhombi. So since quadrilateral PQRS is both a rectangle and a rhombus, it is a square. It's a square. It's a square. Oh, help me, please.